Hi there, and welcome back to 355 Code. Today we will be doing the second part of our JavaScript beginner tutorial, Make Your Own Othello game. In the first part of this tutorial, we showed basically how to build this Othello board, which you can see here is a 8x8 grid with a green background, and when you click, pieces are laid out alternating between white and black to simulate each player taking a turn. If you didn't see the last video, then I recommend you check it out. I'll have a link here in the description of this video, and you can basically see the code is already all written out here. If you followed through last time or you built the board and functionality by yourself, then in this part we will be creating the logic of the game. So what do we basically need to do here? We need to flip pieces so that, for example, if I have a white here and another white here, then any pieces, and the pieces between them are black, then these would need to be flipped into white. And that would need to be true also horizontally, also vertically, and in both diagonals. Okay, so we're going to break down this problem. We're going to take it one step at a time, and we're going to start just with one direction. Okay, so let's first think about downwards. Okay, so when I put a piece, I want to basically check all the pieces below it. So let's just write this out basically. Check pieces below. And if we reach another piece that is the same color, if reach piece that is same color, okay, then we are going to go back and flip the pieces in between. Okay, so let's just kind of show how that would work here. Okay, so I have a white piece here, and I'm going to put a few black pieces in between. And then as soon as I place this white piece down here, basically what our code is going to do is it's going to run through all the pieces below it. And it's going to check, is this the same color as this piece? No, so it'll move on to the next one, and so forth until it hits one that is the same color. And that way, let's say we have either no pieces in between, let's say, in this case, or two pieces of the same color, then basically the code will stop and it won't execute and no pieces will be flipped. And this will have to be true also if the code reaches the edge of the board. And the way that we increment our array will be different each time. For example, when we're going from right to left, then we will increment by 1. When we're going from left to right. And when we're going from right to left, we'll be incrementing by -1. When we go from top to bottom, then we'll actually be incrementing by 8, because basically, if you imagine that our whole board is one long array, and then this, for example, right up here we have 7, then this right over here is going to be 15. And that's how we're going to need to check things out. So in order to build the logic of this game, we're going to build a logic that's separate to the game board. So we're not going to be using the information that's stored in the game board itself in terms of the HTML elements, but we're going to build a completely separate logic, and we're going to store it all in an object. In an array of objects, where each object will basically represent one of these pieces. So let's get to building that logic, and I'm really going to build it kind of right up top here, at the top of our code. So basically, what we're going to be doing is we're going to be creating an array. So let's just call that array game, and it's going to be blank, a blank array. And then we're going to be looping for 64 times, right, to go through each piece. And each time we're going to push a new object into this game array. So I equals 0, and then as long as I is smaller than 64, we are going to run through this loop. And what are we going to want to do here each time? So let's think about what kind of information we're going to need here for each piece. So let's declare an object, and we'll call this piece object. Okay, and this piece object will have several keys. So first of all, we'll give it a number, which will identify where on the grid it is. And these numbers will go from 0 to 63, and basically we'll just use I to keep track of this. So let's just say grid number will be equal to I, and then we'll have a color. So all of our pieces will start off with the color blank, and then we'll be changing this this key to either white or black, depending on what it is when we flip pieces later on and when we add pieces later on. And then another thing that we want to keep track of is this piece on the edge or not? So basically, in order to keep track of this, let's just call this edge, and we're gonna define these edges by having an array, and we'll just call this edge array, and we're gonna need to figure this out soon. So after we create this object piece, basically what we're just gonna do is game.push, and this is just going to be piece object. Okay, so we built this out basically, and now we need to figure out the whole issue of the edge array. So we have 4 edges. We have top, bottom, left, and right. And basically what we're going to do is we're going to create 4 arrays. And each of these arrays is going to consist of the numbers of the indexes that would be on a certain edge. So I'm going to declare these right under game, and I'm just going to call them top edge, and bottom edge, and right edge, and left edge. And basically what I did is I sat down and I figured out which numbers each of these arrays should contain by looking at a grid. And just the important part here is to remember basically that we're starting from 0 and not from 1. So top edge would be 0, 1, 2, 3, 4, 5, 6, 7. Because there are, remember, there are 8 boxes on each side of the grid, on each edge. And the bottom edge is going to be 56, 57, 58, 59, 60, 61, and 62, and 63. And the right edge is going to be 7, 15, 23, 31, 39, 47, 55, and 63. And you don't need to do this all by hand. You can actually just copy the code. It'll all be in the description below. I'm just writing it out here, so the people who do want to follow along can do that. And you'll see that there are also some doubles here. So you'll see that 0, for example, is in 2 of the arrays. It's both in top edge and left edge, and that's because those are the corners. And this is going to be important for us later on because the corners will present a certain challenge when we are figuring out our logic later on for what to flip and what not to flip. Let's just finish filling out these arrays. 48 and 56. Just gonna make sure I didn't miss anything. Great. Okay, so now basically we know what our edges are, and basically for each time we loop through this this function, we're going to want to figure out if a specific I belongs to one of these edges. And if it does belong to one of these edges, then we're going to push a certain term into this edge array. And each edge array will have two items. If it is on a regular edge, it'll be just twice the name of the edge. So let's say it'll be top top or bottom bottom. And if it's a corner, then we will put one for each of the edges. So let's actually write that out and you'll see what I mean by that. So let's first declare edge array. So we have what to work with here. And then here, basically what we're going to do is create another array. And this array will be made up of 4 sub-arrays. And basically it'll say bottom edge, and then bottom, and so on and so forth. So top edge, top, and left edge, left, and right edge. Put this inside an array. 1 second. Right. And basically the idea here is that these are basically the names of our arrays, so we can't really push, we don't want to push the entire array into edge array. We just want to push kind of like a shorthand that we can use a simple string. So this is basically kind of, you could think of it as a conversion array, which basically converts between you know, each of our declared arrays and a certain term that will replace it. And then basically we're going to run through each of these sub-arrays. So I'm going to use a for each here. And we're going to call these edges, basically. And let's run through this. And what we're basically going to check is if edge 0, so that will basically be the arrays up here, bottom edge, top edge, left edge, etc. If it includes I. And if it does, then edge array dot push edge, sorry, let's spell this correctly, edge 1. Okay, so if the array includes I, that means that this specific box is on an edge, and then we will push our our term into the edge array, and then this edge array will be placed into our piece object, which will be pushed into the game. And then basically for the all the edges, we will have arrays that that include the terms for their edges, and for those that are not in the edge, we will just have a blank array. So let's run this, and then let's console game right over here. So let's run our code, and we'll see if we have any bugs or anything like that. Okay, unexpected token, amazing. Already running into some challenges. Dot for each. Okay, so here I didn't write out the whole for each correctly. Okay, and this we need to close over here. Amazing. Let's try that again. console.log. Great. So here you can see we have our game, and it's made up of 64 objects from 0 to 63, and each one of them has grid number, the color, and the edge. So this is our top left edge right over here, and this is over here, so this is top, etc., etc. And if we just pick some random one here in the middle, we'll see that we have an empty array here for the edge. So great, so we have our board set up, and this is basically the logic. Okay, so you don't see this visually, but we're going to be using it to figure out if we need to flip any pieces throughout the game. So next, let's think a bit about how we're going to write out this logic for the flips. So the first thing we're going to want to do is check out the piece that is right under the piece that we just placed. And remember, we're just doing one direction now, which is checking down. So basically, what we want to do is we want to check if this piece that's right under it is either blank or if it's the same color. Because if that's the case, then we don't even need to do anything. So let's set up a. I'm going to do this using a while loop. And this logic is all going to go right here within our event listener for click. So basically each time we place a piece down, it's going to run this whole logic to check all the pieces that are surrounding. Great, so what we want to do now is basically, first step is we want to figure out where a piece has just been placed. So we just placed a piece, and what we want to do is get the ID for this piece. So basically, let's just declare a new variable, and we'll call it grid index. And basically, what we're going to want is to tap into the to grid, which, if you remember, we're within the event listener of grid. So it's basically this specific place where the event was just, this element where the event was activated. And what we're going to want to tap into here is the attribute of ID. So we're going to do that with get attribute and ID. And our ID, if you remember, up here is, let me find that. So it's called grid dash plus I. So we want to kind of single out just the I here. So in order to do that, we're just going to use substring and 5. Okay, so this is basically going to get just from the fifth character in the string onwards. And I'm going to wrap this all in a number because this will give us back a string, and basically we want to be dealing with numbers here in terms of our grid index. Great, so now as we said, the next thing we're going to do is we're going to want to declare a variable which is going to be called, let's just call it 1 below. And this is basically equal to grid index plus 8. Okay, because remember, if I place a piece right here on top of this piece, then if I want to check what the white piece is here, then I need to count 8 forward here, and then I'll be right below this black piece, because we're just basically, this is one long array of from 0 to 63. And basically what we want to do is check out now the keys within the object that we created earlier within the array of the game. So basically I'm going to use a while loop, and what we're going to want to do, as we said, is if the one right below it is not the same color and not blank, then we're going to want to keep on checking down and down. Okay, so while this one below, okay, while one below, okay, dot color is not equal to blank, and one below dot color is not equal to grid index. Sorry, grid dot color. Okay. And what we're going to do is we are going to one below plus plus. Okay, sorry, plus, so it's not plus plus, it's plus equals 8 because we're doing increments of 8. So basically it checks one below, and if it falls into certain criteria, then we go one more down. Because basically what we're just trying to get to now is get to the final piece from which we're going to work our way back up. Okay, great. So now we have the logic for working our way down. Okay, one thing that I realized that I did wrong here is that one below is basically the index of the item that we're going to want to check within game. So we're going to really want to write our code out like this. And also in terms of grid, and here instead of using grid, I'm going to use game and grid index, just so that we're using the same logic, right? We said we don't want to tap into the elements, the HTML elements themselves. We want to really just use the logic that we created for, you can think of it as some sort of backend for our game. And now basically what we want to do is when we exit this while loop, so remember this while loop will terminate when basically we reached a certain piece that doesn't fulfill these conditions, and that means it's time to work our way back up. So now basically what do we want to do? So if the piece that we hit that ended the while loop is the same color as the piece that we just placed down, we are going to flip pieces. Otherwise, we're not going to. So let's put that condition in. So that means that if game one below, and it's a little confusing because one below is actually not one below anymore. So you can kind of call this something else if it's confusing you. And maybe I would even change it in my final code, but let's just work with what we have done right now. So if the color is equal to the color of grid index, which is the piece that we put down, then what are we going to do? We are going to loop through all the pieces from one below until the top piece. So let me really just well, saving is always good. Let me just kind of make an example here that would be okay. So this is the piece I just put down is grid index, and so we check one below, it's black. That means we continue checking. Also black, we continue checking. Also black, we continue checking. White. Okay, stop checking. And now check, is white equal to white? Yes, it is. That means we want to loop back up and check these all out. But if, for example, we had something like this, okay, so we would do the same thing. We would keep on going down until we reached this last one, which is blank. Okay, and remember that's something that terminates our while loop. And that means that we need to check, okay, is the color of this blank, quote unquote, equal to white? No, it's not. So we wouldn't even go back and flip anything over. And I'm kind of going into this stuff because I think that is one of the main challenges when it comes to coding, really translating from what you want to achieve in the real world and translating that into code that needs to be written and the logic that's behind your code. So let's write out that for loop. So how is this for loop going to work? So let's start off I equaling to 1 below. And we're going to kind of work our way back. So as long as I doesn't equal to grid index, sorry, one too many equals here, because you could think that we're basically kind of, as long as I does not equal to grid index, so basically you could think we're going back up, and here I is not equal to grid index, we'll check here again, etc., etc., then it won't stop. And then we're going to basically, each time we will reduce I by 8. And that is because on the way down we were adding 8, on the way up we're going to basically reduce by 8. And now what are we going to be doing within this loop? So what we're going to do is we're going to change the color of this piece into white or black, depending on what grid index was. So we have to do this in 2 layers because we also need to change the color of the element, and we also need to change the log, quote unquote, of the color within the game logic. So let's start with the logic. So game I dot color will be equal to game grid index dot color. Okay, so that basically changed it within the logic of the game. And now we need to really access the piece that we want to change. So let's say that piece, let's just call it piece to change. And remember, this will change each time as we go through the loop. And this will be equal to document dot get element by ID. And let's see what we called, what kind of ID we gave to each piece. And as I look back in the code, I see that we didn't really give any ID to the pieces. So this would be a great place to add it in. So basically, we're going to give each piece an ID, and we're going to do that set attribute, just like we did up here for the grid. And the ID, and it'll be equal to piece plus I. Okay, so now each of our pieces also has an individual ID, and we can use that now to flip the piece back over. So we're going to get element by ID, and the ID will be piece plus I. And now we can basically just say piece to change dot style dot color equals game grid index dot color, and that should flip our pieces over. And instead of color here, we're going to use background color. And let's try running our code and see what happens here. Okay, cannot read this properties of null. So let's try and figure out where there is a mistake here. Piece to change, style, background color. Let's see if we called it up here. Piece plus I cannot read properties of null. Okay, I'm just trying to look at the code and see where we might have some kind of mistake. Okay, so basically our problem is here is that we, we're not flipping anything because there's nothing really below this piece to check, so it's blank, and a lot of our logic here isn't working. So we're going to ignore this. We're going to ignore this for now, and we're going to address these kinds of errors later on. So let's just place some more pieces, and I put a piece on top and nothing flips. So the reason this is happening, and I knew this would happen, is because we didn't really incorporate the logic of the game when we were creating the pieces to begin with. So basically right up here when we're creating these pieces, let's say right where we declare the color right over here. So let's just tap into game, and this is going to be game I, right? We're using the logic from up here, and dot color will also be equal to game turn, right? Game turn is how we defined the color of the pieces when they're first placed down. So let's try running that code one more time, and I'm gonna, whoops, that's not what I want to do, black, and you can see that when I put a white piece over here, and there was a black piece in between that and the white piece, then we flipped the pieces in between. So that's great. I mean, that basically means that we've basically figured out the key logic of the game, and now we just kind of need to replicate this for other directions. And before we do that, I just want to address one loophole that we haven't bridged yet, and that is that we haven't really addressed the whole edges issue. Because basically what you'll see here is, let's say I have, I'm going to create the situation so you understand it. So basically we're checking down. So basically, let's say I have black here, and then I put another black here, and let's say I put a white over here. Let me try and figure out why that didn't create an issue. Okay, so it's less of an issue for the up-down direction, because once we increment another 8, then there's nothing really to check below, and that's kind of why we're getting this error over here. But in the right left, it's a little more visible. Basically what I'm trying to say is that we need to add edges as a condition in our while loop. Okay, because if either grid index is an edge, if this is an edge, then I don't really want to check anything below it. Okay, that's it's not necessary. It's going to throw back errors. And if any of the pieces that we get to within our while loop are an edge, then we're done. So basically, within this, the conditions of this while loop, we're going to add a few more conditions to make sure that our piece is not an edge. And it's best to get it out of the way now so we don't encounter it later. So what do we not want to be an edge? So we basically want game grid index dot edge. Okay, that's basically how we're going to check if something is an edge or not. And basically we're going to check if this edge includes bottom. Okay, and why bottom? Because bottom is kind of bottom is what we're checking now. Okay, we're checking from top to bottom, so we need to check if this edge includes bottom. And actually, what we need to do is okay. So for now, that will suffice. And let's just add one more condition, and we'll check that one below is not an edge either. So game grid index dot edge dot includes bottom. And very important not to forget here is that we want to add exclamation points right before here, because we're actually looking for the negation of this logic. We don't want them to be equal to the edge. And let's just run our code again to make sure everything's working. Yeah, okay, so the code is still working. We're still getting some errors here. But for now, since the code is functional, I'm going to choose to move forward and work out those errors later on. So basically what we need to do is now we need to replicate this code for all of our different directions. And this video is already getting quite long, so I'm actually going to stop here. And if you want to see the rest of the code and logic behind this game, you can check out the next video. We'll turn this into a 3-part tutorial. So I hope you enjoyed this tutorial so far. If you did, please don't forget to like and subscribe. And this should really give you enough tools to work out the rest of the logic of the game yourself. We've taken you maybe 80–90% of the way. But if you're not sure how to do it, you will be able to check out the next video of the tutorial. So thanks for watching, and I'll see you next time.